Number 26, each of the 25 cells in a 5 by 5 grid of squares is filled with a 0, 1, or 2 in such a way that the numbers written in neighboring cells differ from the number in that cell by 1. Two cells are considered labels if they share a side. How many different arrangements are possible? Okay. Observation. If a square is filled with 0 or 2, its neighboring squares must be filled with 1. If a square is filled with 1, its neighboring squares must be filled with 0 or 2. And okay, we will start with the center square. Center square here. Okay, if the center square is 1, then okay, the right square will be the neighboring square. It will be either 0 or 2. 0 or 2. Okay, if this is 0 or 2, then the neighboring squares will be 1. Okay, if this is 1, then those will be 0 or 2. Okay, etc. You go, okay, expand out, you see a pattern like this, a checker pattern. Okay, so look at the red squares. You have 13 red squares. Each square can be 0 or 2. You have two choices for a red square, and there are 12 red squares. So the total number of choices or total number of arrangements for this case is 2 to the power of 12. Okay, 2 times 2 times 2, and okay, 12 times is 2 to the power of 12. Second case, the center square is 0 or 2 here. Then the neighboring square will be 1. Okay, 1 will be the white squares. Then the neighboring squares will be 0 or 2 here. Okay, so you will see a checkerboard like this. You will see, okay, there will be 13 red squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 red squares. Each red square can be 0 or 2. So the total number of arrangements will be 2 to the power 12 plus 2 to the power 13. You take that 2 to the power 12 out, then times 2 plus 1, okay, that's okay, or 1 plus 2, that's 3. Okay, but 2 to the power 12, okay, if you multiply 2 multiply 2 multiply by 2, will a lot of multiplication there. But you should memorize that 2 to the power 10 is 1024. So 2 to the power 12 is 2 to the power 10 times 4. 4 times 3 is 12. Okay, and this number, okay, 1024, then times 12. You don't do the multiplication. You want to find the answer mentally. Okay, you do this. This one is not. This is just one less than 1025. 1025 times 12 is easy to calculate. Okay, this will be 12,000. Then this times 12 is 300. 12,300. Then 1 times that is 12. You do simply do the subtraction. That's easy. Okay, 12,288 is the answer. Number 27, starting with a square side length 1, a square side length half is drawn so that it is bisected by side of the original square as shown. This process is repeated with a square side length 1/4, bisected by the square side length half, and so on without end. What would be the area of such a figure when generated by as described? Express your answer as a common fraction. So the picture is drawn here. You have a square, then draw another square, the half of the sides, and this is exactly the middle of this side. Then you draw a square as half of this one, and this is the exact middle of this side, and they go on forever. Then we want to find the area of this. Okay. And some people will just do this. This area is 1, this area is 104, this area is what? 1/4 of that is 1 over 16. This area is 1 over 32. Then 1 over 30, 1 over 64. You just add those numbers. Okay. Some people remember this formula like sum of a geometric series, but this is an infinite series. You add an infinite many of numbers. Okay. That's you might have a formula, but we don't need to know that. Okay. We don't need to know that and to find the answer. Look at here. This smaller figure here, because it goes forever. This is just an exact replica of the big one, except you have the size halved. Yeah. So if S is the area of the big figure, okay, the right side figure is exactly replicate of the original one, except the original dimension halved. So the area of this is 1/4 of the area of this original one. So S, the big one, minus 1/4 of S, this one, should be this white one. The white part, the area is easy to find. That is 1, okay, that is 1/4. Half of 1/4 is 1/8. So 1 minus 1/8 is 7 over 8. So S minus 1/4 S is 3/4 of S equals 7 over 8. Multiply both sides by 4, then you divide both sides by 3. You find the answer S is 7 over 6. So the area of the original figure is 7 over 6. Okay, that's pretty easy. Number 28, in regular pentagon ABCDE, point M is the middle point of side AE, and the segments AC and BM intersect at point Z. If ZA equals 3, what is the value of AB? Express your answer in simplest radical form. Okay, first, the answer will involve a radical form. So usually square root. Okay, it involves square root usually. So if you get a fraction number or a whole number, that's wrong. And second thing that okay, you have no idea what are those points. So you got to draw a picture here. So draw a regular pentagon. Okay, regular pentagon A, B, C, D, E. Segments AC, that's a diagonal. Okay, and here, okay, M is the middle point of AE. AE here, middle point. That's the middle point. Then AC and the BM, okay, BM intersects at the point Z. So that's Z here. ZA equals 3. ZA equals 3. That's given. What is the value of AB? AB is this side. So we want to find the side here. Okay, notice here I label this X as X because we want to find it. It's better you say it's X if you cannot give the answer right away. You say X. We want to find what X is. And this question is pretty complicated. Many students miss this question, and some of them just make a guess. So let's see here. First, if you know the side, you should be able to find the diagonal. Okay. The length of the diagonal of a unit regular pentagon is the golden ratio. Okay, the golden ratio omega equals 1 plus square root of 5 over 2. So we will use this fact, golden ratio, this number, okay, is the diagonal of the regular pentagon if the length is 1, if the side length is 1. Okay, we can find this using similar triangles. Okay, but we will use this, otherwise it will be takes too long. Okay, so we will use diagonal, use the fact that the diagonal will be omega if x equals 1. But if the length of the side is x, then the diagonal will be omega times x. So instead of writing that 1 plus square root 5 over 2 times x, I will just write omega x. It's simpler, but just remember omega is this number. Also, something about this number is that this number is the positive root of the equation x squared minus x minus 1. Okay, the number golden ratio is the positive number, which satisfies this equation. So we will use the fact omega squared minus omega minus 1 equals 0 to simplify the solution here. Like look at here, this is omega x. Of course, AC is also omega x. So CZ will be omega x minus 3. Okay, that's omega x minus 3. And look at it here. Okay, those two lines intersect at M, and M is the midpoint of AE. So because here AB is parallel to CN, okay, this look at the symmetry here. AB is parallel to this line. So okay, the triangle here MAB is congruent to triangle MEN because those two sides are the same. Okay, this angle is same as that angle. If the lines are parallel, this angle is same as that one. This angle will be same as that one. So those two triangles are similar, but also the two sides are the same, so they are congruent. If they are congruent, that means AB is same as NE. Look here. So that's X. Once we find this, we use another pair of triangles here. Okay, AGB, triangle AGB is similar to triangle CZN because the two lines CN, AB are parallel. So you have two similar triangles. Similar triangles have sides, proportional. So look at the corresponding sides. This one corresponds to this one. So omega x minus 3 over 3 is the same as this side, omega x plus x over x. So we get this equation here. Omega x minus 3 over 3 equals omega x plus x over x. This is an equation about x. We will solve this out. Okay, multiply both sides by 3. Move that to the other side, divided by omega, we get this. Okay, you got 3 omega plus 3, then you add 3 again. You get 3 omega plus 6, then divided by omega. Okay, you get this. That's x. But omega is given. Okay, you can put this number in there, simplify it. But I will use this fact, okay, to simplify this. Instead of put this in there, simplify, I will use this to simplify. Why? 3 omega, factor 3 out, okay, then this omega plus 2 omega. Omega over omega is 1, 2 over omega, okay, then 1 plus 2. 2 over omega. What is 2 over omega? In order to simplify this, I look at here. If we move this 1 to the other side and divide both sides by omega, you will get 1 over omega. Okay. Move this negative 1 to the right side and divide it by omega. Then 1 over omega is omega square over omega is omega. Then minus omega over omega is 1. So you get this 1 over omega is omega minus 1. So 2 over omega is 2 times omega minus 1. So, okay. This way, I don't need to put this number in a denominator. You will complicate the solution. Okay. So we want to make it simpler. Okay, get rid of the denominator and simplify this. Then you see that you put it in there. Okay, 2 omega will be 1 plus square root of y. Then minus 1 you get square root of y. So the answer is 3 times square root of y. It's much simpler. Okay, answer 3 times square root of y. It has a square root in there. Number 29. 50 tickets numbered with consecutive integers are in a jar. 2 are drawn at random and without replacement. what is the probability that the absolute difference between the two numbers is 10 or less? Express your answer. Sorry. Express your answer as a common fraction. Okay, 50 tickets numbered with consecutive integers. You can assume those tickets numbered from 1 to 50. Okay. There are 50 choose 2. You have 50 tickets, choose 2. The number of ways to choose 2 tickets, 50 choose 2. And it's easy to know, to find this number. It will be 50 times 49 divided by 2. Yeah, you draw 2 tickets. First one, you have 50 choices. Then your second one, you only have 49 left. Second ticket, there are 49 choices. So 50 times 49. But in fact, the order. The first one might be A, the second one B, but another choice will be first is B, second is A. They will the two tickets will be considered one choice. So that's why you divide it by 2. Okay, so divided by 2 will be cancel 2. You got 25 times 49. Don't multiply this out. Okay, if you multiply it out, you do extra work and you find out. Okay, it will not help you. So let's count the number of ways that 2 ticks have absolute difference 10 or less. Assume that the 2 numbers chosen are A and B. Okay, they are different, so A cannot be the same as B. And let's say A is a smaller one, so it's A less than B. A can be any ticket except ticket 50 because B is bigger than A. Okay, so A can be 49, but it cannot be 50. Okay, the first case is A is less than equal to 40. If A is less than equal to 40, because B is a bigger one, B can be the 10 numbers after A. Okay, so for example, A is 1, then B is 2, 3 until 11. If A is 40, then B is 41, 42 until 50. So B has 10 choices. Okay, so know what A is. B has 10 choices, but A has 40 choices. So its total number of choices in this case is 40 times 10, 400. If A is greater than 40 but less than equal 49, okay, then B can be A plus 1 until 50. From A plus 1 to 50 is you have 10 minus A choices. Okay, for example, if A is 41, B can be 42 until 50. That's 9 choices. 9 choices. If A is 42, B can be 43, 44, 50. You have 8 choices. Okay, if A is 49, B has only 1 choice. So you add those choices, number of choices together, you get 45. Okay, you should know how easy it is. Okay, 9 plus 1 is 10, 8 plus 2 is 10, 7 plus 3 is 10, 6 plus 4 is 10, you got 40, then 5. So the number of ways that the 2 tickets have absolute difference 10 or less is 400 plus 45, 445. And divided by the total number of choices, 25 times 49. Okay, it cancels a factor of 5. You get 89, then the bottom is 5 times 49. Okay, 49, 7 times 7, you see there's no factor 7 in the numerator. So this is already simplified. So you multiply this bottom out. You got 245 in the denominator. The answer is 89 over 245. Number 30. How many ways are there to arrange the ticket to digits 1 through 9 in this 3 by 3 grid, such that numbers are increasing from left to right in each row and increasing from top to bottom in each column? Okay, the top left number is 1. So here, in this square is 1 because that's the smallest number here. Because all the numbers here will be bigger. Okay, all the numbers here will be bigger than this. All the numbers here will be bigger than that. So you see that's smallest. But all, in similar way, this one is the biggest. So this will be 1, that will be 9. But okay, if that's 1, 2 can be here or here. If 2 is here, 3 can be here or here. If 3 is here, 4 can be here. Or if 3 can here, then 4 will be here or here or here. Okay, there are a lot of choices. So if we count that way, it will be endless. So we want to use cases. We want to use cases to manage, okay, how we count. So this is already fixed 1, that's already 9. A lot of special squares in the middle. So let's see here the middle. Okay, the middle, because here that's 1. This is smaller than the middle. This is smaller than the middle. So at least there are 2 numbers smaller than the middle. So the middle number is at least 4. At least 4. So it can be 4, it might be 5, might be 6, but it cannot be 7 because here you have this square and that square bigger than here. That's 9. So 7, 8. 7, 8. At least you cannot put 7 here. If you put 7 here, then only 8 for those 2 squares. That would be wrong. So the middle can be 4, 5, or 6. So we'll use those cases here. Okay, let's see if middle is 4. If the middle is 4, okay, the 2 right square, okay, either 2 or 3. If here is 2, then it's 3 here. If it's 3 here, then it's 2 here. Okay, so you have 2 ways to fill the red ones. Then you have 4 left. The 4 left one will be 4, 5, 6, 7. Okay, 4, 5, 6, 7. You choose 2 to put it here. Okay, and once you choose 2, okay, the smaller will be here, the bigger one will be here. The remaining 2 will be here in the correct order. So choose 2 from those 5, 6, 7, 8. Choose 2 from 4 is 6. 6 ways to fill in those 4 squares. So you multiply 2 with 6 is 12. So if the middle square is 4, you have 12 arrangements. Is the middle number 6. Okay, but how about in this way? Uh, this one, if the middle is 5, okay, if the middle is 5, what you have 3 numbers before 5, like 2, 3, 4. So 2, 3, 4, it might be here, 2 here, 1 here. So if we want in here, okay, you choose 1 from those 3 numbers, put it here, then the remaining 2 will be here in the correct order. So you only have 3 ways to fill in the red squares. Okay, so the remaining 3 numbers, 6, 7, 8, will be here and here. So we'll look at this one. This one, the blue one, okay, you just choose 1 of them from here to put it here. Then the remaining 2 numbers will be in the correct order. For example, if you choose 7 here, put 7 here, then 6 must be here, 8 must be here. Okay, so you have 3 ways to fill in these 3 squares, and you have 3 ways to put in this here. 3 times 3 is 9. Okay, 3 times 3 is 9. But how about, okay, in this configuration, this 3 red one will be 2 here, 1 here. So it's similar. You choose 1 from the 2, 3, 4, put it here. So it's 3 ways to do this. Then choose 1 from 5, 6, 7, no, 6, 7, 8, put it here. There's 3 ways to fill in those 3 squares. So it's 3 times 3 is 9. Okay. So you have 9 arrangements in this configuration. How about if the middle is 6? Okay, if the middle is 6, it's same like this. Okay, same like this. So you will have 12 arrangements. So Okay, 4 in the middle is 4, you have 12 arrangements. In middle 6, you have 12 arrangements. So 12 plus 12 is 24, 12 times 2. If you have 5, okay, you have 9 for this, 9 for this, so 9 times 2, total is 24 plus 18, 42. So this is pretty cool. So here you use case and you try to see what will be the middle. Okay, the middle is not fixed, but there are cases. There are cases. So that's good. Okay, that's all for those 30 questions, and see you next time.